Is the heat death of the universe a real thermodynamic threat? Imagine the universe as a giant energy puzzle slowly losing its pieces. Over time, the energy becomes more spread out, and the universe reaches a point where nothing changes anymore. That's what scientists call the heat death. It's based on the idea that energy moves from hot to cold, which is a fundamental part of thermodynamics. Let's start with what heat really is. Heat is a form of energy transfer that happens because of temperature differences. When something hot touches something cold, heat flows from the hot object to the cold one. This transfer can do work, like powering engines or keeping us warm. But heat is just one way energy moves around. The first law of thermodynamics tells us that energy cannot be created or destroyed. It can only change forms. So, the total amount of energy in the universe stays the same. But the second law says that in any energy transfer, some energy becomes less useful. This increases the disorder or entropy in the system. Now, applying this to the universe, think of it as a big, closed system with a limited amount of usable energy. Over billions of years, stars burn their fuel, turning organized energy into dispersed heat and radiation. As the universe expands, this heat spreads out even more, making it less concentrated. Eventually, the universe will reach a state where temperature differences no longer exist. No hot or cold spots, no energy gradients. Without these differences, heat cannot flow and no processes can happen. Everything becomes uniform and inert. This is what scientists call the heat death. Is this a real threat? From a thermodynamics point of view, yes. If the universe keeps expanding and no new energy sources appear, it will tend toward this state. The heat death is not about the universe becoming hot. It's about it becoming uniformly cold and lifeless because energy is too evenly spread out to do any work. This scenario is predicted to happen in the future, on timescales much longer than the current age of the universe. But it's based on solid scientific principles. The universe is not a simple closed system, and dark energy influences its expansion. Still, the idea that entropy tends to increase remains true. Understanding this helps us see how energy governs the universe's fate. While it's not an immediate concern, it shows us that the universe is evolving toward a state where no thermodynamic activity can happen anymore. The heat death is a real possibility, rooted in the laws of thermodynamics, where maximum entropy means no more energy differences to sustain processes or life.